going to start with the Roborio. The Roborio is this little gray box, and it's the brains of the electrical components, so it communicates with the computer, and it's what allows us to upload code to the robot to allow it to function. And you always want to make sure that your Roborio has this purple NavX chip on it, because it's what allows the robot to drive properly. And if it doesn't have that on there, or if it's malfunctioning, then you're going to see some weird stuff with your wheels, especially with things like swerve drive, because it's super sensitive when it comes to things like angles, and the NavX is all about determining angles. The next thing we've got is the VRM, which stands for Voltage Regulator Module. The only thing that plugs directly into it is the radio, which essentially just sends out a Wi-Fi signal that we connect to on our laptops.
Okay.
And then the next thing is the PCM, which is the pneumatic control module. So that controls all of our, it's the brains between all of our pneumatic systems. So the solenoids plug into it, the compressor down there plugs into it. Pistons, well, I guess pistons plug into the solenoids, and then they plug into that. But it's important that you have that if you're going to have any solenoid components, but you don't need it if you don't have any. And then these are just, these are just solenoids. So that's the top bit, just defining. And then on the bottom, it's kind of a mess because this is our practice robot, but you have the PDP, which stands for Power Distribution Panel. So this powers all of our motor controllers and our motors via the motor controllers. And it also powers all this stuff up here. So it powers the Roborio, the VRM, and the PCM via these little things down here that'll teach you how to open and close later. Next thing we've got is our motor controllers. So on this robot we mostly have old Talons because it's a little bit older, but we also have these new SparkMaxes that come with encoder cables that plug directly into their radios. You do the design process, so the team decides what they want, then they prototype it, and then the CAD team finalizes your design. And so normally you'd keep asking when the CAD team's done with all of their stuff, or when they're done with the electrical components. So you'd say, how many motors do I have? What kind of motors? And then how many pistons do you have? Because the motors and pistons determine what you have on your electrical board. So let's say they said you have 16 motors and no pistons. Okay, well that eliminates this, so you don't need this, but it also fills up all of the PDP. So you need to make sure that your bottom layer, and that's another thing, the heaviest stuff always goes on the bottom if you're doing a layered electrical stuff. So the PDP is the heaviest, and then if you combine all of these motor controllers, it adds up to a whole lot of weight. So you always want them on the bottom, so that way you don't tip over and you don't break anything. So you would have 16 motor controllers down here, which I think we do on this robot. And this is not a good example of wire organization because it's a practice robot, and I think we know we're in a hurry, so it's all kind of junked. You never want it to look like this, because then your issue is you can't troubleshoot stuff. So let's say the software team's like, this middle wheel isn't working. Well, how do I know what motor controller goes to this motor that's driving the middle wheel? Well, you can't tell because it's messy. So organization is going to be your best friend on the robot for electrical components, because when it's like that, it's incredibly hard to troubleshoot. And on competitions, you need like quick troubleshooting to get problems out of the way. So it's all on one layer, and it's organized. So you have the pneumatic system over here, and then the brains over there. And actually, what's kind of interesting is that they're not all on the same piece of polycarb. They're kind of like held up bits of polycarb. So it was fun to put together. But we also have on this here robot, it's all SparkMaxes, so there's no Talons, and it's not confusing to keep track of what's what. And there's no Talons, as you can see, on top of, or there's no SparkMaxes on top of the motors like there was on that year's robot, because we have these little boxes, and inside these, oh no, I don't want to do that. Inside these, there's a little board that essentially just extends the encoder cables from this point all the way up to these little like Neo Maxes. It is a little bit different than your normal tank drive mainly because since they're upright, this thing right here, this little gold tube, is an encoder that measures the angle of these gears and the angle of the motors. And a lot of the times, if you see like one wheel like flipping out, that's because this isn't properly plugged in here, or it's got little bits of metal that are shorting out its pins, or it's not properly plugged in onto the Roborio, or it's got little bits of metal shorting out its pins. So if you see like wheels going like, I need a wheel, tape, like that,
Yeah.
you know that you have an encoder problem. Like, that's not a power thing, because it's obviously getting enough power to like jiggle everywhere, and you know that it's getting signal because it's trying to follow a command, it just can't.